This lesson is over inequalities. Before you say, oh my God, what is this? It sounds complicated. No, it's greater than and less than. You've learned this, or more than or less than. You learned this since elementary school. You learned this since you were a kindergarten kid. Because someone can say, I have more than you. All right, so fix this mistake. Let's look at this number routine. In this number routine, it shows x divided by 5 equals 6, and they say the answer is negative 30. Is that correct? If I replace this x with negative 30 divided into 5 groups, would that be positive 6? No, it would be negative 6. So we know there is a mistake somewhere here. But the question is, where is the mistake? So let's find the mistake. So they divided by 5. To solve any one-step equation, you do the inverse. What is the inverse of dividing 5? Multiply by 5. First of all, I already see my first mistake. Here they multiplied it by negative 5. It should be multiplied by 5. This should be multiplied by 5. This cancels out. So the answer should be 30. 30 divided by 5 is 6. All right. So now, I would like you, we're going to be, in the beginning of class, we're going to be grabbing things. So to make sure you understand what more than and less than using real world situation. Grab less than 8 towel. If someone say to grab less than 8, is it okay to grab 1? Could you grab 0? Could you grab exactly 8? No, it has to be less than 8. So you can grab 7. So you can grab from 1, 0 to 7. Grab more than 8 towels. Can I grab 1 towel? No, it has to be more than. Can I grab exactly 8? No, it has to be more than. So it could be 9 and 2, the limit of your bag. Next one. Grab at least 8 towel. At least. Let's see what that means. At least, I need to grab at least 8. Is 2 the least I can? No. 3, 4, 5, 6, 7. 7 is a grab at least 8. Is 7 enough to meet this? No. The least I can grab is 8. But I can grab more. So this would be from 8 to infinity, to more, wherever the limit of the bag is. I can grab 8 and continue on. So at less than and more than is something you should have seen in 5th grade or younger. At least is something we start in 6th grade in adulthood. Grab at most. The most I want you to grab is 8 towel. You better not grab more. The most, at most. So, is it okay to grab 1? Yeah. Is it okay to grab 8 tiles? Yes, I can, because the most I can grab is 8. Is it okay to grab 9? No. So the answer would be from 1 to 8, or 0 to 8. Grab less than or equal to 8. So what are numbers less than 8? 0, 1, 2, 3, 4, 5, 6, 7. Can I grab equal to 8? So it's 0 to 8. And grab more than or equal to 8. So I need to grab numbers more than 8. It's like 9, 10, 11, 12. And it keep on going. But it could be equal to 8. So 8 and to the limit of the bag. So there are symbols that we are going to represent. Instead of saying it in word form, we can write it using inequality symbols, such as this. This symbol represents the less than, or fewer than, or below. For example, x could be any number. Give me some numbers that are less than 5, like 3, 4, 2, 1.7, 8, less than 5. How do you know that this is the less than symbol? Some elementary schools teach it like you draw 1 dot for the lesser side. So this side is lesser than that one, so x is less than that. So this is the less than, but we're adding a second component to called the equal to. Less than or equal to. It also means at most, no more than, maximum, not greater than. So for example, in here, whoops, Here is x is less than or equal to. It could be less than 5 or equal to 5. Or it can be the most, it can be 5. It can't be more than 5. It can be 5 is the maximum. It cannot be greater. So what numbers satisfy this? 4, 3. What about 5? Yeah, because the maximum could be 5. It can't be more than 5, but you can have 5. 5 could be the most. It cannot be greater than 5. What about this one? This symbol is called the more than, greater than, above, exceeds. If you are problem to figure out the differences between a less than and greater than, some elementary school teach it like this side has 2 dots, this side has 1 dot, this side is bigger or greater than this side. So give me some numbers that are greater than 5, 6, 6.5, 10, 8. Give me some numbers above 5. Those are same. Exceeds 5. And the last one, this is the more than, and this means equal right here. It means at least, cannot be less than, minimum. 5, it has to be more than or equal to 5. 6, 8, 9, 10 and a half. 5 is the least it can be. Are these good? It can't be less than 5. What about 5? Am I allowed to use 5? Yes, you can. Minimum is 5. So now we are going to practice making a number line with them. So P is less than 10. Give me some numbers. Give me a number. Give me 2 numbers that are less than 10. 8 and 7. So the way you graph it is you put 10 in the center, name 2 units to the right of it, whole units, and 2 units less than 10. So it has to be less than 10. So in our previous lesson, when it's equal to something, you draw a black dot on it. It cannot be equal to 10 because it has to be less than 10. So we draw something called an open dot. Then you highlight numbers that are less of it. Is 8 and 7 and 9 are less than 10. So this represents less than. V has to be less than 10. It could be equal to 10. So let me first write out my number line with 10 in the center. 11, 12, 9, and 8. Give me some numbers that are less than 10. 9 or equal to 10. What about 10? So if it can be equal to 10, it is called a closed dot so that it can be part of this answer. Now we have to highlight numbers that are less than 10, which are all these numbers. 8 less than 10, 9 less than 10, 10 equal to 10. M is more than 10. So let me write 10 here, 11, 12, 9, 8. So M has to be more than 10, has to be greater than 10, bigger than 10. So bigger than 10. So it could be like 11 and 12. Can it be 10? No, it has to be more than 10. So it's an open dot because if I can color it in, close it up, you're saying that 10 could be the answer. We have to highlight numbers that are more than 10, 11 and 12. And our last one, W has to be more than 10. So let's put our number line first. W has to be more than 10, like 11. But it can be equal to 10. So if it can be equal to 10, it's a closed dot. And which numbers should we highlight are more than or equal to 10? 11 and 12. So we're going to be using this to help us out throughout the lessons. So in this story is Simon. So she said on here in this video, she said Simon has asked his crush Nanyu out no more than 10 times. Not more than 10 times. What does that mean using inequality if t is the number of asking out? So we have a 10. So Nan asked out no more than 10 times. Not more than 10 times. So let's think. Is it okay to ask 10 times? Yes. Not more than 10. What about 9? Is that okay? Is 11 acceptable? No, because it cannot be more than, no more than 10 times. So it seems like it has to be numbers that could be 10, 9, 8, or less, all the way to 1. So which one shows equal to 10? So I know it can't be these two, but lesser. Is this lesser? Let's see. I'm pretending I'm elementary code. This side is lesser than this side. T, so number of times is lesser than 10 or equal to 10. That is our inequality. So what you're going to do now is we are going to be solving inequality using algebra tiles. And then we're going to solve it, just solving it mathematically. And then we're going to graph it. So we have a plus 4 is less than 6. To draw this, I use the algebra tile of a variable. So it's a variable, a, plus 4 units. It has to be less than 6. How do I get rid of these positive units? What can I take out to cancel it out? I take out negative units. But like a balance scale, whatever I do on one side, I have to do on the other side. And what happens when you have a positive and negative unit? They cancel out. All this goes away. All this goes away. So we have a is less than 2. And that is our answer. Let's solve it mathematically for those who do not so want to solve it through algebra tiles, which I don't blame you at all. You have to isolate the variable. How can I get rid of plus 4? The inverse is minus 4. I subtract 4 from both sides. This cancels. A is less than 2. So let's graph this now. So we put a 2 here. Name two numbers that are greater than 2 and two numbers that are less than 2. If it has to be lesser than 2 or less than 2, can it be 2? No, it has to be an open dot. So what numbers are lesser than 2? Well, 1 and 0. So I highlight this side. Test points mean let's check our work. Let's plug in a 1 and 0. What's 1 plus 4? 5. Is that less than 6? Yep, it works. So 1 plus 4 is 5 is less than 6. It works. Next one. Using algebra tiles, can you represent 2 is greater than g minus 5? So I'm going to use my algebra tiles. I'm going to model it. So I have 2 is greater than g minus 5. How can I isolate this variable? How can I get rid of these negative 5 units? I must draw positive 5 units. But like a balance scale, I better draw on the other side or it will disrupt the balance. These are 0 pairs. So 7 is greater than g, which is perfectly good answer. But usually we like the variable to be on the left side. So 7 is greater than g. So g must be less than. Do you see how it's facing the lesser side? G must be lesser than 7. What if you want to solve this algebraically? How can I isolate g? I need to get rid of minus 5 with plus 5. Plus 5. This cancel. 7 is greater than g, or g is less than 7. Let's graph this. So this is a 7. What are two numbers larger than 7? 8 and 9. What two numbers are less than 7? 6 and 5. So if it's less than 7, can it include 7? No. Open dot. Now we need to highlight numbers lesser than 7. 5 and 6. And let's use our test point. Let's prove it. Which up is 6? 6 minus 5, 1. Is 2 bigger than 1? It is. Here are our last two test points. And then 3m. So I take out 3m, my algebra tiles. 3m. And a greater or equal to negative 9. Each m, I need to divide them into groups of m. So these 3 go to this one, these 3 go to this one, this 3 go. So it seems like m is greater or equal to negative 3. How could I solve this using algebraically? Again, an inequality is just like an equation. Instead of using equal, we're using what the inequality gave us. So I inverse of multiply is divide. I divide both sides by 3. This cancel. M is greater or equal to negative 3. And let's graph this. So this is negative 3. What two numbers are greater than negative 3? Negative 2, negative 1. What two numbers are less than it? Negative 4 and negative 5. So if it can, M has to be greater, but it can be equal. So open dot or close dot? Close dot because it could be equal, be part of this. Name some numbers here that are going to be bigger than negative 3. Remember, the greater side is this side, so I highlight the greater side here. Let's use some test points. I'll pick negative 2. 3 groups of negative 2 is negative 6. Is negative 6 bigger than negative 9? It is. If I owe $6 compared to someone who owes $9, that person has more than the other person. And our last one, you have x that is divided into 2 parts. Each part has 4. So each half has 4 units. Each half has 4 units. So what would a whole unit equal to? X would be less than or equal to 8. How can I solve this algebraically? Because I think it's so much faster solving algebraically. It's inverse of divide 2 is multiply 2. Multiply 2, just cancel. X is less than or equal to 8. And let's make a number line. This is 8. What two numbers are larger? 9 and 10. What two numbers are smaller? 7 and 6. So if it has to be less than or equal to 8, could it be equal to 8? Yep. So I close dot. Which numbers are lesser or equal to 8? 7 and 6. So let's use some test points. Let's use 6. 6 divided by 2 is 3. 3 is less than or equal to 4. That's one. So it's a lot of things we're covering today. It does take about 4 days to learn this lesson. So we are going to be practicing the next few days on this.